So, why study calculus? What even is calculus? It's my turn to take one class and explain why and what it is. So, simply put, calculus is the mathematical study of change. Now, please note, everything is changing. Every breath you take, your body is, cells are dying, cells are being replenished. You're growing. Everything around you is changing, which is one of the reasons that calculus becomes so important. So calculus was invented simultaneously but separately by Isaac Newton and Gottfried Leibniz. So these two gentlemen were not communicating with each other at all. They lived in completely different places. Newton is from England and Leibniz is German. And yet, at the same time, these two gentlemen both discovered or invented, however you prefer to think of the creation of mathematics, the same thing. They both came to the same conclusions, but completely separate from one another. That's one of the beautiful things about math, guys, is it's just true. There's nothing subjective about mathematics. Newton and Leibniz noticed the same things. And it actually, the fact that it was discovered by two men at the same time actually led to a rift in the mathematical community. Because what happened was Leibniz was far more willing to publish his work. So Leibniz started to publish about the calculus. And Newton went, hey, wait, I already discovered that. And he started to publish his work. And so what ended up happening was this rift where for 100 years, I want you to think about that, 100 years, the mathematicians in England did not communicate with their counterparts on the continent. They didn't talk to the mathematicians from Europe for 100 years because of this argument over who should get credit for calculus. Can you even imagine that? And what ended up happening was that England kind of fell behind. The English mathematicians kind of fell behind because they were lacking that interaction. So they weren't getting all of the information from the continent. That's not the point of our course, but this is something that people have felt passionate about for a very long time. So, mathematical study of change. So, yeah, this is what I imagine you're thinking right now. Right, the study of change. But what could it possibly have to do with our lives, right? Like it's already been discovered or invented. No sense in it anymore. Except before calculus, all we really had, we had algebra and we had trigonometry and we had geometry. And that was pretty much it. And so everything we did was very limited. Science was very limited because they didn't have ways to explain or model what was going on around them. And then all of a sudden, calculus comes along, and calculus makes physics make sense. And then from there, everything starts to grow, and we see this big surge in information and understanding as all of a sudden we can predict what's going to happen because we can use this math to model what's going on around us. And then from there starts being all these offshoots. And so once we had calculus, we started getting what has now become modern analysis and modern algebra and all of these different higher level mathematics. So calculus is not the end. Calculus is really, in the grand scheme of things, it falls right in the middle. Okay, you've graduated from the really basic stuff, but it doesn't even really begin to touch all of the amazing math that's still out there. But a lot of that math couldn't really begin to happen until we had calculus. So you need this. You need this little middle ground to help the rest of it make sense. And then the rest of it is what makes your technology happen. So the fact that you are listening to my voice and looking at the same slide that I am really has a lot to do with calculus and the mathematics that came after it. The fact that we can now safely transmit banking information through the air, that's advanced analysis. That's how we do encryption. And again, that comes back to calculus. So please understand that this is such a huge part of everything, of how scientists and science have shaped and continue to shape our world. So I have this example because I got real heated, like really heated. So I was getting ready for work and my husband had the Weather Channel on and they were talking about Hurricane Laura. Laura had just made landfall that morning. And the meteorologist said that the river behind him had risen 8 feet over 4 hours. And he concluded from that the river had risen 2 feet per hour. But as you and I know, rain doesn't fall at a constant rate. He assumed a constant rate of rainfall. Okay, if I say that over 8 hours, that it grew 8 feet over 4 hours, so it must have done 2 feet per hour, I am assuming that things were constant. But rainfall is not constant. So what he should have said is that it grew at an average rate of 2 feet per hour. Because really, in some of those hours, it grew faster. In some of those hours, it grew slower. And not just hour by hour, minute by minute, that rate changes. And what calculus lets us do is analyze those very small time frames that things are changing over. And in fact, we get to where we study instantaneous rate of change. So we're talking how fast something changes like that. Calculus lets us figure out how fast I go from walking to running. So I'm walking, and then all of a sudden I'm running. You can figure out how fast that change in my velocity was. You can figure out that acceleration rate. Calculus, however, does not explain why I was running, but it does let you figure out how fast I changed my rate. And then, of course, there's my favorite calculus problem. Guys, I learned this problem when I was in high school. I was a junior sitting in Mrs. Lowe's classroom. That's now the math lab. So I was sitting in that classroom right here in this high school, and we studied this problem, and it has stuck with me ever since. So you pass a cop who's running some radar. You're doing the speed limit when you pass them, so they leave you alone. Okay? 15 miles later, you pass another cop while doing the speed limit. Okay? So when you pass that second cop, you're doing the speed limit. But that cop pulls you over for speeding. Why? Calculus. And we will look at this exact problem later this semester. I don't want to give it all away. I will tell you, though, that there are states in the Northeast that use calculus and technology together to catch speeders just like this. So, I mean, in conclusion, calculus made possible things that weren't before. Like, I hope you all stay and you all explore this with me. Calculus isn't always easy because it's completely different, but without it, there are so many things that we would not have and that we would not be able to do. And I am really looking forward to sharing this amazing subject with you this year.